Okay, so we will solve today May 2019 paper. Alright, ESE paper, May 2019. Okay, so let's start with the first numerical. Okay, the first numerical is using node voltage analysis, determine the power consumed by 2 ohm and 4 ohm resistance in the network, and this is asked for 10 marks. So our first job is to draw the circuit as it is. So this is question number 1A. So you all can also draw it, join me in drawing the circuit as it is. So please draw it over here. And keep a calculator in handy near you. And we'll aim to complete the 10 marks numerical within 15 minutes time. So right now the time is around 11:23. Okay, this is 1 ampere, 2 ohm, 1 ohm, this is 3 ohm, 4 ohm, 5, 6 ohms, and this is 6 volt. So what we need to find is, we need to find power consumed by 2 ohm resistance. So I am writing P 2 ohm and P 4 ohm. Okay, and we have to do it by nodal analysis. Okay, so can I maximize this so that I have written the question? Okay, can we start? You'll have completed the diagram. All right. Yeah, students.
Yes.
Okay, so let's start one by one. So the first job in nodal analysis is defining the nodes. So let's define the nodes. This is my reference node. So this will go to the ground. Then I have this node over here. Let me call this node as A, and the voltage across this will be VA. This node will be B, and this node will be C. Is there another node required over here? No, not required. So these three nodes are enough. Alright. So this will be VB, and the voltage across node C will be VC. Okay. Now we will define the currents. So let's say current flowing into 1 ohm resistance is I1. Current flowing through 2 ohm resistance is I2. Current flowing through 3 ohm resistance is I3. Current flowing through 4 ohm resistance is I4. Okay, first of all we define all the currents. This is I5 and this is I6. Okay, clear? We have defined the currents in all the branches. Alright, and this is outgoing only. This is like 1 ampere current source also we have to consider. So you'll have done the markings. Can we start now?
Yes.
Okay, so now let's apply. Now we know nodal analysis works on applying KCL. So let's start applying KCL at node A. So our focus is node A. This is our node A. How many currents are there in node A flowing inside? This is also there. This current is also there. So tell me now, what are the incoming currents? What are the outgoing currents?
Incoming current is 1 ampere.
Yes, and I1 and I2 are outgoing, right? Yeah, so what do we, yes, yes, so what do we write over here? I1 plus I2 is equal to 1. Is that correct? Incoming current is equal to outgoing current? Okay. Now, tell me what is I1. I1 is VA upon 1, correct? This you agree? I1 is VA minus 0 upon 1 actually, but VA upon 1. Then what is I2? VA minus VB upon 2. Here it is, I2. VA minus VB upon 2, correct? And that is equal to 1. Is this alright? Then we have VA upon 1 is VA. So VA plus 0.5 VA, that becomes 1.5 VA minus 0.5, half is 0.5, VB is equal to 1. Let's call this equation number 1. Everyone followed this step? Yeah? Yes, no, so that we can
Yes.
proceed? Okay, good, great. So please write this equation and get this equation number 1 ready. Alright? Now let's move on to the next one now. Let's focus on the node B now. B. This is my node B. So tell me the KCL equation. So we'll write KCL at node B. So KCL at node B is, what are the incoming currents, what are the outgoing currents? Anyone? Hello?
Incoming is I2, right? And outgoing would be I4, I3.
Yeah. So what we can write is I2 is equal to I3 plus I4. Correct? So I2 we already know it is VA minus VB upon 2. VA minus VB upon 2. What is I3? I3 current is what?
VB upon 3.
Yeah, VB minus 0 upon 3, that is VB upon 3. And I4 is?
VC minus VB upon 4.
No. See, it's starting from, see where the current is going. Current is originating from VB and is going towards VC. So it's VB minus VC upon 4. Got it?
Okay.
Yeah, please be careful about the direction of the current. So it's VB minus VC upon 4. Now this we need to simplify it. Don't take the LCM. Okay, directly we'll solve this. So that is, see how I am solving it. Very calmly you have to do this numericals. 0.5 VA minus 0.5 VB is equal to, what is 1 by 3? 0.33, never ending 3, right? VB. 1 by 4 is 0.25 VB minus 0.25 VC. Now this will simplify it further. So here we have 0.5 VA, then you have minus 0.5. This VB terms will collect it on that side. So minus 0.5 minus 0.333 minus 0.25. How much it is? Can you all tell me? 0.5, 0.333 and 0.25. What is the addition of these three? Anyone? It's 1 point something, right? Can you all tell me what it is? So 0.5 plus 0.25 is 0.75. 0.75 plus 0.333 will be 1 point. Can you tell me the answer? Actually, I will not go to the chat section. Orally, can you tell me? 1 point. How much?
083. 1.08.
Never ending tree, right? Then this 0.25 will go over there, so it will become plus BC. So is equal to 0. This becomes equation number 2. So please write down this. I mean, you have noted down, right? Can I scroll here now?
Yes.
Okay. Now we have to apply KCL at node VC here. C, node C. Okay. So let's start writing KCL at node C. So tell me, what are the incoming currents and outgoing current?
I4 is incoming, I5 and I6 is outgoing.
There is none under the, here this is not going.
1 ampere is also output.
Yeah, correct. So I4 will be equal to I5 plus I6 plus 1. Is that correct? Alright. So I4 is VB minus VC upon 4. I5 will be VC upon 5. Can you tell me what is I6? Now this is something new, so tell me I6. Hello? Anyone? What is I6? VC, what will come?
-6
Yeah,
upon 6.
yeah. VC minus, because you're going from plus to minus, so it will be VC minus 6 upon 6 plus 1. Alright. Now we simplify this. 1 upon 4 is 0.25 minus 0.25 VC is equal to 1 upon 5 is 0.2, right? 0.2 VC. Then 1 upon 6, how much it is? 0.16667 VC. Then minus 6 upon 6 is minus 1 plus 1. Agree? This is the calculation. So here minus 1 and plus 1 will get cancelled, and then you will get, we club the terms together now, 0.25 VB minus 0.25 minus 0.2, so minus 0.45, and then minus 0.1667. So how much it becomes? It becomes 0.61667 times VC is equal to 0. So this becomes equation number 3. Are you getting the same equation? Are you getting the same equation? Let me know. Yes, no, what? Are the values same as what is shown in the screen? Come on, tell me quickly. So after this step, what we do is we make a matrix. We write in a matrix form VA, VB, VC. Okay, and here we write the coefficient of VA, VB, VC and the constant. So first term is 1.5, second is minus 0.5, third coefficient VC is 0, and this is 1. Okay, this is equation number 1. Then equation number 2, we have 0.5 minus 1.0833 and 0.25, and the constant term is 0. Here we have VA as 0, VB as 0.25 and VC as minus 0.6166, okay, 7, and this is 0. Now we have to solve this simultaneously in your calculator. So plug in these values in your calculator and let me know the value of VA, VB and VC. So take some few seconds and solve this and let me know the answer. How much is VA, VB,
So
VC?
actually for VC I am getting the coefficient as 0.11667.
How? See here, na?
0.25
Minus
minus
0.25.
0.2 minus 0.1667.
So add them together, na? See how much you get. Correct it is? You have to add them together, na? Because all of them are minus now when you take on
Yes,
this side.
yes, sorry, it was my
No,
mistake.
no problem, no problem. Mistakes you do it here, but not in exam. Okay. So here anyone can tell me what is the value of VA, VB, VC? Because I'm waiting for it. Plug in these values in the calculator as it is, if you are getting the same, and let me know the value of VA, VB, VC, so that we can move ahead. Come on, time is running. Anyone would like to say the values? Yeah. What is VA, VB, VC? You have to put it in the equation mode where you enter these values. How much is VA? Hello. So are you all getting VA as 0.8029 volt? Just cross check. VB is coming out to be 0.4088 volts and VC is coming out to be 0.1657. Just check. Are you all getting these answers? This is by solving 1, 2 and 3 simultaneously. So you have to use a calculator and get these values. Anyone got these values? Yes or no? Hello? Yeah? Can you all tell me? Are the values same? 0.8029, 0.4088 and 0.1657. As these are the values of VA, VB, VC. Just check and let me know so that we can go ahead. Okay, so let me know this. Now we have to find power across 2 ohm resistance, power flowing through 4 ohm resistance. So what is the power formula? Power across 2 ohm resistance will be current flowing through 2 ohm resistance square into 2 ohms, right? Similarly, power across 4 ohm resistance will be current through 4 ohm resistance into 4 ohm, correct? Anyone got these values correct? Yeah, let me know fast because we are checking the time also, how much time we are taking. Okay, what is I2 current flowing through 2 ohm resistance given by VA minus VB upon 2? So I2 will be VA minus VB upon 2, and then what will be I4 current flowing through 4 ohm resistance will be VB minus VC upon 4. So I4 will be VB minus VC upon 4. So please cross check these answers. If this is correct, then this will be VA is 0.8029 minus 0.4088 divided by 2, and that comes out to be, just check this value, 0.19705. Is this value correct? Anyone checking? VB is 0.4088 minus 0.1657 divided by 4. So I of 4 ohm resistance will be, current through 4 ohm resistance is 60.775 milliamperes. Are you getting correct nearby values? Yes or no? Hello? Please check these values. These values might differ. So I2 square, so it will be 0.19705 square into 2. That's the value of power across 2 ohm resistance. This is power across 4 ohm resistance will be 60.775 milliampere. Milliampere meaning into 10 raised to minus 3 square into 4. So let me know the value of power across 2 ohm resistance and power across 4 ohm resistance. I suppose you are getting up till here correct. So this will come out to be 77.65 milliwatt, or you may get it as 77.65 into 10 is to minus 3 watt. One is the same. Here this becomes 14.774 milliwatt, or you can write it as 14.774 into 10 is to minus 3 watts. Please check whether you are getting the similar answers or no. So right now the time is around 11:42 and we have taken more time to complete this. So we started around at 11:23 and we have taken around 11:42. So yeah, 19 minutes we took to complete this. I was also waiting for you all, so we can subtract 2-3 minutes from there. So around 16 minutes we took for completing this numerical. That's close enough. So you all got the answers similar? Yes or no? Tell me, so that I can go ahead and solve the next numerical.
Yes.
Answers are matching? Alright, if answers are matching, then we go to the next numerical. Now we'll increase the speed a little so that we will match the timing as if we are solving a paper. So we'll go to second numerical, 1A, and again for 10 marks. Use source conversion, reduce the circuit into a single current source in parallel with a single resistance. So basically we have to use source transformation. Source conversion means source transformation. So let's write down the question. Again it is 1A or question. So you have to use source transformation over here. And what do we want with the source transformation? Entire circuit gets converted into a single current source with parallel with a single resistance, like this. So we want the entire source to get converted into this I and this R. Let's say this is ISRS. Okay, so what is the original circuit? Let us draw. So this is our circuit is. This is 10 ampere. Then we have 2 ohm. Then we have this 5 volt. This is 3 ohm. This is 2 ampere current source. Then we have 4 ohm resistance and we have 6 ohm resistance. Okay, so please draw the circuit. Have you completed drawing? Can we start?
Yes.
Alright, this is again a 10 marks numerical. So right now time is 11:45. We have to complete before 12. So let's start. I'll little bit increase my speed because I think you have done this type of numericals before also in the class. Can we start? Okay, fine. So now, what do you see? We can convert. We know what is source transformation, right? So what we can do is, let me suggest one thing. Let me just make it full screen and then we'll start. So let's say that these two resistances, these two resistances are in parallel. So 4 ohm is in parallel to 6. How much is the answer? 4 into 6 divided by 10. So it's around 2.4 ohm, right? Correct? So this is the first case. We'll convert this into one resistance. So let's redraw the entire circuit again. Yeah, we have to do that every time. Okay. Source transformation numericals, we have to draw the circuit again and again until we are left out with a single current source with a single resistance. This is 2.4 ohms. This is how much? 2 ampere. This is 3 ohm, 5 volt, 2 ohm. Alright. Now what do you see? What can we convert? Can we convert this current source with a parallel resistance to a voltage source with a series resistance? Yes or no? Hello?
Yes, sir.
Yeah. So let's do that. Let's draw it. So I'm drawing the circuit again as it is. This is 10 ampere. This is 2 ohm. Up till here it will remain same. Now I have to add the voltage source. So what will the voltage source will be? Current going from negative to positive. So current going from negative to positive. And in series we will have a series resistance. Let's say the series resistance is over here. Yes or no? This resistance will be same. What about the current voltage source value? This voltage source,
4.8, right?
yeah, 2 ampere into 2.4, that is 4.8 volt. Absolutely correct. Now how do we proceed ahead? This is the challenge. Now can you see?
Can we convert the 10 ampere one?
No, I will say we'll keep on reducing from the right hand side, go towards the left. Are you understanding? So here you see now opportunity is there to merge these two resistance together because they are in series, right? Yes or no? So we can say 3 plus 2.4, which becomes 5.4. What else we can add? Can we add voltage source in series? Yes or no? So you have two voltage sources in series. So this is one voltage source and this is second, from here to here, let's say, from A to B, let's say. So this is 5, this is how much? 4.8. So what will get converted into? This is minus plus, this is plus minus. So going from here to here. So how much is the voltage source? Can you tell me? This is minus. So it will be, how it will look like between A and B again? So this will be,
0.2 volt.
but where it will be directed? Like this, correct?
Yes.
A, B, and this will become 0.2. So let's do that together. We are doing two steps together. So this will be 10 ampere current source. Parallel we have 2 ohms. Now this will become like this. 0.2 volt in series with what? 5.4 ohm.
4.
Correct? Now tell me what we will do next. Convert this voltage source and series resistance into a current source with a parallel resistance. Alright? So please do it simultaneously along with me. 10 amperes. This is 2 ohm. Now tell me the current direction. How it will be? Whether it will be going from down to up or up to down. Whether the direction will be same as 10 ampere or opposite to 10 ampere. Tell me. And a parallel resistance will be there. So tell me the direction. This is 5.4.
Opposite to 10 amperes.
Absolutely correct. Absolutely correct. Okay. Normally what we say is, if this is my voltage source, my current direction is directed from negative to positive. So here is directed from negative to positive, that will be down. What is the value of this current source? Can anyone tell me? This value is what? This value will be voltage.
Volt upon resistance.
Yeah, absolutely correct. 0.2 upon 5.4. How much is that? 0. Can you tell me this value?
0.037.
Amperes. Yeah, that's the value of this current source. 0.037 amperes. Correct. Now tell me what can we do now? Now, if there are two parallel current source, can we add them together? Yes or no? Hello?
Yes.
And if we have two parallel resistance, we can add them together, correct? So 2 parallel to 5.4. Tell me how much it is. Um, and this will become 10 minus 0.037 amperes. So this will be 9.963 amperes. Can you tell me 2 parallel to 5.4, how much is the value?
1.459
ohms. Yeah. So finally we will have one current source which value is 9.963 ampere, and in parallel we'll have a single resistance 1.459. So yeah, at the end we got a single current source with a parallel with a single resistance. So that is the answer, and this is correct.
Sir,
Yeah.
in the third step, if we convert 10 ampere and 2 ohms coil,
Yeah, we can do that. See, this if you connect together, then they will get converted into a voltage source, right? So then voltage source would have added together. All three would get added together. Yes, we can do that. That is what you are saying, na?
हाँ तो उसका आंसर अलग आ रहा है लेकिन एक बार आप ट्राई कर सकते हैं
Which answer? For this one?
When
Yeah.
you change 10 amperes and 2 ohms into a voltage source, the answer is differing almost by 1 point.
I'll tell you why. I'll tell you why. Why? You know, in source transformation, there is a technique. Either you start from left or right. Don't start from both together. Are you understanding? So either keep this 10 amperes intact and solve from right hand side, or you solve from left hand side and keep right hand side intact. If you solve by both the ways, then answer will definitely come wrong. Are you getting it? So here we were solving by left hand side, right? From the right hand side case. So don't convert everything at the end. Keep this intact till the end. Are you getting what I'm saying?
Okay, sir.
So complete from right hand side or left hand side, not both. So complete entire right hand side first, and then whatever is left out will be your single current source with a parallel resistance. Or what you could have done is from the start of the numerical, start from left hand side and go up till right hand side at the end. Got it? Hello?
Yes, sir.
Okay. So yeah, that is it. We started at around 11:45. Right now it is 11:55. So we went quite fast here. So 10 minutes for 10 marks, that is ideal. But provided you do not make any mistake. Alright. So source transformation is also revised now. Let's go for the next numerical. Is the pace okay or am I too fast? Yeah, can I go with the same pace?
Yes.
Alright. Now there is another numerical 1b. Will everyone complete it, right? Can we go to the next one? This is, I think, 1b. Yeah, 1b. So let's see what it is. Determine the current through resistance RL equal to 3 ohm in the circuit by using Thevenin's theorem, and hence draw the Thevenin's equivalent for 10 marks. So our aim again should be complete within 15 minutes. So let's start drawing the circuit. So it's an example of a Thevenin's. So Thevenin's and Norton's are quite equivalent. So we'll solve it by Thevenin's, that's fine. So let's draw the circuit quickly. You all also draw it in your books. This value is around 150 volt. This is 4 ohm, 6 ohm, 3 ohm, 5 ohm, and this is 20 volt. Alright, let me focus on this now. You have to solve by Thevenin's theorem. We all know what is Thevenin's theorem, right? So we have, this is RL. Okay, so this is A and B. Alright, so what's the first thing we do in Thevenin's theorem? We'll find the value of RTH. Then next we'll find the value of VTH. And next we find the value of load current IL. In this case it is I of 3 ohm. So can we start? Completed drawing the circuit. So for RTH what do we do? Anyone knows? For RTH what are the steps? Number one step is remove RL, and second step is find resistance between point A and B, right? Yes or no? So we can write find RAB, and next step is deactivate all sources. So if it is a voltage source, what will happen to the voltage source? It will become a short circuit and current source will become open circuit. So let's redraw the circuit with this analogy. So here we have 150 volt, is a short circuit, 4 ohm. Okay, this will be 6 ohm. This is just A, this is just B, open circuit. Then this is 5 ohm, 5 ohm. This will be short circuit. Okay, yeah, now tell me the next step. How to calculate RAB? So RAB is over here. Okay, can I say this 4 ohm and 6 ohm are in parallel, or they are in series? Anyone can tell me? No, they are not in series. See, they both the terminals, yeah. See, they both the terminals are tied together. So 4 ohm parallel to 6 ohm. How much it is? 6 into 4, 24 divided by 6 plus 4, that is 10. That is 2.4 ohm. Correct? Then also can we say this 5 ohm in the same way and this 5 ohm are in parallel? Yes or no? Yeah. So same resistance when they are in parallel, the value will be half of the. So this is 2.5 ohm. Alright. Now this circuit gets reduced to, so you have a resistance between 2.5, this is point A, right? And at point B you have 2.5. Now what is RAB? Can you tell me what is RAB? Are they in series or parallel now? So it's like drawing like this. Series or parallel?
4.9 series.
Correct. So RAB equal to RTH is equal to 2.4 plus 2.5, that is equal to 4.9. Absolutely correct. So 4.9 answer is the correct one. Okay, can we go to VTH now? Completed this. So in Thevenin's theorem, if you complete till VTH, you are assured of 3 marks for VTH RTH step. Then we go for VTH. So can we start with VTH? Everyone ready? Okay. So for VTH, what do we do? Anyone? We remove what do we do over here? Remove RL and calculate open circuit voltage between A and B, right? Calculate VAB. Yes or no? So let's draw the circuit again. As it is, only keep A and B open. So this is A, this is B, open circuit. Rest everything you draw it as it is. This is 20 volt, 5 ohm, 5 ohm, 6 ohm, 4 ohm, 150 volt. Okay. Now, tell me, how will you calculate VAB? Okay. So please concentrate over here. I am teaching you a technique. Anyone knows how to calculate?
So at first I think we have to calculate the mesh current in both the meshes.
Absolutely correct. That's the first step. Let me just extend it over here. So let's say VAB means what? Voltage across AB, right? So let me draw a temporary line over here. ऐसे होगा ना? Voltage across VAB. Yes or no? Let's say this is VAB. I know it's an open circuit, but can we write it like this? Yes or no? Now let us start from point B. So when you go from point B, we are going like this. Yeah. So this is my arrow. This is the sequence which I am doing, and now internally we'll define the mesh current, because it's actually mesh bhi nahi hai. I mean, it's a mesh, yes, but we can directly calculate. These are independent meshes. So here let me draw the current. So current here in this direction. Let me draw the current here in this direction. This is what you were saying, right? Define the currents.
Yes.
Now you apply the KVL around this internal loop. This I have drawn. This red color supply and this loop. So if you apply KVL there, what do we get? You start from point B. So when you start from point B and you go up till again come and arrive at B. So when you go over here, is this current and this loop is opposite direction or same direction? This direction and this direction are opposite, right? Yes or no? So we write
Yes.
plus 5I2. If they are in the same direction, then negative. Then the 6 ohms, here we are going 6 ohms, and here the current direction is opposite. So again plus 6I1. Yes or no? Now we are going over here from A to B. So when you go from A to B, we are going from plus to minus. So minus VAB equal to 0. Correct? So what is VAB now? 5I2 plus 6I1. Did you understand this technique? Everyone? Followed how we got arrived at this equation? Whatever technique you will apply, you will arrive at this equation only. Understood now? Hello?
Yes.
Okay. So now what we will do is, now we'll solve it. What is I1? How will you calculate I1? I1 is simply Ohm's law. So 150 divided by 4 plus 6, right? How much is this? 150 divided by 10. That is 15 amperes. Yes or no? Now tell me, what is I2? What is I2? So here we were going from minus to plus. So it was plus 150. Can you tell me intelligently how much is I2? Formula?
-2.
Minus 2. Yeah, minus 2 amperes, correct. But what is the starting point? So here we are going from, remember, plus to minus. Here where student make mistake. So when you go from plus to minus, it will be minus 20 divided by 5 plus 5. Is it correct? That will be minus 20 upon 10. That will be minus 2. Absolutely correct. Got it? So do not make mistake of plus or minus. Now calculate VAB. So VAB is 5 times minus 2 plus 6 times 15. How much is VAB or VTH now? So minus 10 plus this is 90, right? 15 6 are 90. So how much it is? Minus 10 plus 90, 80 volts. Did you all get 80 volts as VAB? Yes or no? Hello? Did you get the answer as 80 volt? Anyone? You all are following the technique, right? Or you want me to explain any step? Please tell me, I'll explain that step. So I'm assuming that you have reached up till here. Now we draw Thevenin's equivalent circuit. Okay, ready? Thevenin's equivalent circuit. So what is there in Thevenin's equivalent circuit?
सर एक बार ऊपर कर सकते हो स्लाइड?
Yeah, yeah. Where you want me to help you? Um, what step you didn't understand, or you're just writing it?
I'm just writing it.
Okay, okay. Complete it, please.
सर जब हम लोगों ने वी ए बी निकाला वहाँ पे -5 इंटू -2 होना चाहिए ना, बिकॉज वो प्लस से माइनस में जा रहा है रजिस्टर के थ्रू.
No, see, listen. You're saying this equation ना, ये वाला ना, देखो ये point ना, ये माइनस बोल रहे हो ना तुम?
नहीं KVL नहीं, जब भी हम लोगों ने VTH निकालने के लिए वो किया,
हाँ, 5 into -2, that is -10 only ना.
लाइक प्लस से रजिस्टर तो प्लस टू माइनस जाता है ना, तो नेगेटिव होना चाहिए ना.
नहीं नहीं नहीं, we are going in the opposite direction to the current. See, ये वाला line दिख रहा है, ये this one line, and see this direction. Are they opposite or same?
ऑपोजिट है.
Opposite के लिए प्लस आता
अच्छा
है,
ओके हाँ.
and
Yes, समझा.
same direction के लिए you will get negative, but opposite direction positive. Got it?
यस सर, थैंक यू.
Yeah. So completed up till here. You got VAB as 80 volt, everyone? Yes or no? Can I move down now? You have completed this. I'll give you this PDF, everyone. I'll share this PDF with you all, with your teachers. Your teachers will share it with you. You can check your answers then also. Can we go to the next one now? Thevenin's. So for Thevenin's equivalent circuit, you draw VTH, then you write down RTH, then this is point A and B, and you connect back your RL. How much was RL, I guess? RL was 3 ohms, right? RTH, how much did we get? 4.9 ohm, and this is 80. So now we have to find current IL, or in this case current to 3 ohm resistance. So can you tell me what is current to 3 ohm resistance over here? Very simple, Ohm's law. VTH upon RTH plus RL. So can you tell me this answer? 80 divided by 4.9 plus 3. How much is the answer? Is it around 10? 10.1266. Is this the answer? Can someone confirm? Hello? Can you please confirm this answer, anyone? 10.1266 amperes is the answer. Please check. So Thevenin's equivalent circuit you apply and find out the load current IL. Here the load is 3 ohms, so it will be I3 or IL, which is nothing but VTH upon RTH plus RL. You will get the answer, and current direction will be going from top to bottom. Everything all right? Correct now? Can we move on to the next question now?
Yes.
Alright. So next in this we have question number 2a. Find the current through 6 ohm resistance using superposition principle. So earlier numerical also we have started around at 11:50 something, and we have completed in around 15-16 minutes. That's fine enough. Now Thevenin's takes some time. It takes around, let's say, 20 minutes sometimes. So 20 minutes for 10 marks is also okay. How many marks paper you have in your ISC? 75, right? 75 minutes you have na total? Yes or no?
Yes, sir.
And you have 30 marks. So let's say you have 3 questions to solve. Sometimes it is a split also. So all the questions, let's say, of 10 marks. So 10 marks ke liye, if you give 20 minutes also, you can complete the paper within 60 minutes. Yes or no? Now sometimes इसमें से भी they get a split. You convert 1 into 1A, 1B, 2 into 2A, 2B. So then you get more time. So there is a time crunch in your ISC paper. So you have to not only solve the question but solve the question correctly within time. That's the challenge. Alright, let's go to this, concentrate on this numerical now. Superposition theorem principle. So all the principles have been covered. This is 2A. So we have to use superposition theorem or principle to solve this. So find the current through 6 ohm resistance. So let's draw the circuit. This is 4 ampere. This is the last numerical, by the way. This is 10 ohm. That will be 10 ampere, 10 volt. 3 amperes. Okay, and this will be 6 ohm, 5 ohm, 2 ohm, 10 volt. Alright, and we have to find the current flowing through 6 ohm resistance. So I6 we have to find. Everyone ready with the numerical? So this 6 ohm we cannot touch through entire numerical. So do you know the superposition principle, what it is? You consider there are 3 sources, 4 ampere, 10 volt and 3 ampere. So you consider one source at a time. So let's say you consider 4 ampere current source at a time. So for 4 ampere you calculate I6 dash. Then you consider 10 volt. So other sources will be deactivated when you consider 10 volt. So 10 volt ke liye you consider I6 double dash. Then for 3 ampere current source, other sources deactivated, find out the current I6 triple dash. Okay, and finally you can say I6 is I6 dash plus I6 double dash plus I6 triple dash. This is the way you follow the superposition theorem. Is this the way you know, or you know something different? Is the same technique which you have been taught?
सर ये बहुत लेंथी है, तो अगर इसको स्किप करेंगे तो चलेगा ना?
What skip करेंगे?
मतलब सुपरपोजिशन स्किप करेंगे तो चलेगा ना, क्योंकि ये बहुत लेंथी है, तो टाइम कंज्यूमिंग है ना.
I agree, but what if it is the compulsory question? 10 marks compulsory, you will skip it or what? No, na? See, I know it's lengthy, but it's easy. Superposition theorem is the easiest of all, but they are lengthy, I agree. For instead of 20 minutes, it will take 25 minutes. Now let's see how much time we will take. We are around at 12:15, so we'll complete by 12:30, I am sure. So can we start? Anyway, lengthy hai, we are not here to skip any question right now. If you have an option for superposition, then you may think, but if you don't have an option, you have to solve this, right? So can we start, everyone? So first case we consider 4 ampere current source. Four ampere current source alone. So that means 10 volt and 3 ampere will become deactivated. So let's draw the circuit again. This is 4 ampere. This is 10 ohm. This 10 volt voltage source will become short circuit, right? Then 2 ohm, 5 ohm. This will become open circuit, so we need not draw only. Correct? Now the problem is we cannot touch this. So here we want to find current flowing through 6 ohm resistance, I6 dash. So it's very tempting to convert this into parallel. ना ये समझोगे कि 5 ohm is in parallel with 6. But remember, in superposition, if you want to find the current through a resistor, then we cannot involve that resistor into any kind of transformation. If you make 5 ohm parallel to 6 ohm, there is the end of the numerical. Now, can you tell me how will you solve it further? Any idea?
Source transformation.
Absolutely. Source transformation is very easy. So, what do we convert? 4 ampere 10 ohm, correct? Into voltage source, right? So, what is the value of the voltage source? 4 into 10, 40. In series, you will have 10 ohm, then you have 2 ohm, then 5 ohm, and then you have 6 ohm. Now, what do? Club all these two together. So, this will become 12 ohm, right? Now, how do we find I6 dash?
Again, source transformation.
You can apply source transformation, very good. So, this voltage source, let me show it to you. This voltage source with a series resistance gets converted into a current source with a parallel resistance. So, this resistance value will be 12, here it is 5, and this is 6.
Sir, arrow ऊपर होगा ना?
Arrow will be above. Absolutely. So, this value of the current source will be 40 divided by 12. How much is that? 3.33. Correct? Yes or no?
Yes.
Now, how do we find current source directly now? Tell me, can you tell me directly? I6 dash. Is there any technique we can solve it directly now? Yes, there is a technique. What is it? By current division rule. Yes or no? So, I6 dash will be other resistances. So, what are the other resistances? 12 plus 5 divided by total resistance. 12 plus 5 plus 6 into the current source. If you don't want to apply this technique, then what you do is combine these two resistances, then convert this current source into a voltage source, and then find the current. Safe method. Can you tell me what is I6 dash by this technique? Anyone with the answer? Hello? This is by current division rule. Can you tell me how much is this? 17 upon 23 into 3.33. Can you do?
2.5.
Sorry?
2.46.
With this technique? You better not follow this technique then. 2.46 now, let it be. We'll go by the conventional technique only. Don't follow this CDR method over here with two resistance and more. So what do we do next? We go by the linear technique, the shortcut. We'll convert these two into a single resistance. So 12 parallel to 5. How much is it? Is it 3.5294? Yes or no? Yes or no? Now convert this parallel current source into a parallel current source and parallel resistance into a voltage source. Finally, with a series resistance. This is 6 ohm. Now tell me what will be this voltage? 3.333 into 3.5294. How much is this? Please, can you tell me how much is this? Voltage source value. Hello. How much is the voltage source value over here? 3.33 into 3.5294.
11.7.
So tell me this I6 dash now. How much it is? 1 point something. 11.75 divided by 3.5294 plus 6. What's the answer? 1 point. Anyone? Amperes, and its arrow is down. 1.11 you are getting? Yes or no?
1.233.
11.7. This you multiplied with 4 digits or 3 digits? 11.75.
3 digits.
Okay, if I take 4 digits, let me check what is the answer. For less than 10 value, you take up till 4 digits. 3.3333 into 3.5294. 0.76 you consider, right? Accurately you take it.
1.24 yeah.
Fine. 11.764. Okay. So 11.764. So how much you got now? $1.23, correct? This you are getting right? Are you getting 1.2345?
Yes.
Yeah, so this is the way we can complete this. What is 40 by 12? We do 40 divided by 12. Yeah, that is correct. 12 parallel to 5 is how much? Proper na it is value. Yeah, it's correct. I was just cross checking the answers. Yeah, 1.2345. Alright, everyone. Can we go ahead now with the second part? So for the second part we consider 10 volt voltage source. So 4 ampere and 3 ampere will disappear. So let's draw the circuit again. You consider 10 volt voltage source alone. So let's draw the circuit so that current source will become open circuit. We have 10 ohm over here. This is a voltage source, 10 volt voltage source. Then we have this resistance 5 ohm. Then we have this resistance 6 ohm. So 6 ohm. Now how will you solve this? This current is I6 double dash. Anyone? What technique you will apply over here? Don't think. If it is a mesh, apply mesh analysis. I1, I2. Correct? KVL to mesh 1. So what do you get? Minus 10 I1. Here it is plus minus. So minus 10 minus 2 I1 minus 5 I1 minus I2 is equal to 0. So here minus 10, minus 2, minus 5. So minus 17 I1 plus 5 I2 is equal to 10. This is equation number 1. Are you following? Then KVL to mesh 2. So what do you get KVL to mesh 2? Minus 5 times I2 minus I1 minus 6 I2 is equal to 0. So this becomes 5 I1 minus 11 I2 is equal to 0. Solve this 1 and 2 simultaneously. So this is I1, I2, and here comes the constants. So minus 17, 5, 5, minus 11, here 10, 0. So can you solve this and let me know the answers? I1, I2 value. Are you understanding the technique, right? Yes or no? So tell me what is I1 and I2. Hello. What is the value? Can you tell me? I1 is coming out to be minus 55 by 81 amperes, and I2 is coming out to be minus 25 by 81. Did you get this? And I2 is nothing but same as I6 dash. So this is I6 double dash. Yeah. So that's the answer. You're getting current negative. That is allowed? Yes, that is allowed. So I6 double dash will be, if you convert this, it will be minus 0.3086, right? Direction is down. But if you want to write it positive, you can change the direction of current. It should go above. Got this? Can we go to the next part now? Third part. Yeah, students? Okay. So now we go for 3 ampere current source. So 10 volt and 4 ampere will be deactivated. So let's start. Third one. You consider 3 ampere current source alone. So when you consider 3 ampere current source alone, you are left out with this 10 ohm, then this voltage source will become short circuit. You can check the main diagram. Then you have 3 ampere, and then you have this 6 ohm. This is 5 and 2. Got it? Now how will you find I6 triple dash? Oh, sorry. Can you tell here directly? So are these 2 ohm and 10 ohm in series? Yes or no?
सर
Yes.
मुझे I6 डबल डैश 0.44 आ रहा
How?
मैंने सोर्स ट्रांसफॉर्मेशन लगाया था
Acha, anyone else got 0.3086?
Yes, sir. I2 I am getting minus 0.308.
Okay, so that's correct. You check whether the source transformation values are correct or no. It must be a mistake over there. Because here I am getting the same answer as one of the students, so this is correct. Okay, I6 dash is correct now for all. Okay, now let's do this. Here, what can you say about the next step now? How will you solve it next in this? So can I say this 12 ohm will be parallel to this 5 ohm? So we can say 12 parallel to 5. How much is this? 12 into 5 divided by 12 plus 5. How much is the value? Can you tell me? Yeah. How much it is? 3.5294. Okay. Now I'll redraw the circuit over there. So I have 3 ampere, then I have 6 ohm, and this value is 3.5294. Correct? I want to calculate I6 double triple dash. What will I do next?
current division.
Yeah, you can apply current division rule, but better be safe. You can solve by both the technique. Current division rule means what? Other resistance divided by total resistance. So let me go by the safer technique. Convert this into a voltage source with a series resistance. So this is 6 ohm, this is 3.5294. How much is the value over here? Voltage source ka 3 into 3.5294. How much is this? Can they tell me? 3 into 3.5294. It is 10 point. Okay. 10.5882. Correct? Now you can find I6. This is I6 triple dash. So what is I6 triple dash? 10.5882 divided by 3.5294 plus 6. Correct? So calculate I6 triple dash divided by 3.5294 plus 6. Tell me how much it is. Is it 1.111? Just cross check this value. Direction is down. Is it correct? Yes or no? So finally, by a superposition theorem, we can say I6 is, oh sorry for this, yeah, I6 is I6 dash plus I6 double dash plus I6 triple dash. How much is I6 dash? 1.2345. So 1.2345. How much is I6 double dash? Minus 0.3086. So it is minus 0.3086. Correct? And how much is I6 dash? 1.1111. So add them together. How much is the I6? Can you tell me? It will be 2.03. Yes, is this the answer? Please cross check this answer. So this is what we get by superposition theorem. Yeah, let me see if in this any other DC circuits theorem are there. No, in the entire paper DC circuits is only up till here. So this was the last numerical of May 2019 paper, and with this answer, so that will be it for today's session. Okay, if you have any queries you can ask. So this is the answer we get by superposition technique, and we have taken around 22 minutes to solve this. For superposition we took around 22 minutes. for 10 marks. Okay, so let me stop the recording.